Hey everybody, this is Mr. Hogg coming to you today with a lesson on 8-5. We're talking about linear, quadratic, and exponential models today. If you will go ahead and turn to page 354 in your workbook, and you should see these examples at the top of the page. That is page 354. And we'll be flipping back and forth between a couple of pages as we go. Just wanted to say we miss you all and hope you're doing well. Hope your lessons have gone well so far with these videos, and I appreciate the other math teachers all coming together to help make these videos. So on page 354, we're again looking at linear, quadratic, and exponential functions. Two of those we've already studied this year. We studied linear quite a bit at the beginning, and we also studied arithmetic sequences that went along with that. And exponential we studied as well, that went with the geometric sequences. And we want to compare how these different types of functions increase or decrease, and how we can use those for different types of models. So let's start with the one that should be most familiar, and that is a linear function. Now linear just means we have our variable and just the variable to the first power. No exponents with that variable and not using the variable as an exponent. And linear functions have what we called a common difference. This just means that we are adding or subtracting the same amount each time as our x progresses, our y's are changing by that same amount. So this is when we're adding that common difference. It could be a positive or negative value that we're adding. And we're looking at these in tables on this page, so I want to start looking at a linear table. So if you will, flip to page 356, and I want to look at question number 5. Question number 5 is a table. We notice on all of these the x is increasing by 1 at each step, and we need to look at how the y value is changing. And for this one, we see that going from 2 to 7, we have added 5. And going from 7 to 12, that is also adding 5. 12 to 17 is plus 5. And 17 to 22 is plus 5. So that tells us that this table is modeling a linear function. Okay. So let's flip back now to 354 and we can continue looking at the other two types. So back on 354. The next one that we need to look at is the other one we've done this year already, and that is an exponential function. And for exponential, remember the x is the exponent in an exponential function, and we were looking for what's called a common ratio instead of a common difference, a common ratio. And with a common ratio, that just means that we are multiplying by the same thing each time. So on the tables on the right, part B is an example of an exponential function. We can tell that because looking at the y values here, in order to get from 4 to 12, we could say we are adding 8, but that pattern would not continue for the next one. If we added 8, we would be at 20, not at 36, so we know it's not linear. So the next thing we could look for is, are we multiplying by the same thing? So to get from 4 to 12, we would be multiplying by 3. And to get from 12 to 36, we would again be multiplying by 3. And you may need a calculator at this point, but 36 times 3 is 108, and 108 times 3 is 324. So this is our common ratio of 3. And that tells us that this table represents an exponential function. So the new one we're looking at in this unit, we've been talking about quadratics. So for quadratics, if we're looking at this table, we're not going to have a common difference. We're not going to have a common ratio. We're going to be looking a little bit deeper into the difference and look at what's called the second difference. So for the quadratic, we're looking at the second difference. Okay, so what does that mean? It means we find the difference between the numbers like we did in the linear table. And then we're going to find the difference between the differences. And you can write that phrase down if that's helpful. We're looking at the difference of the differences. Okay, it's going to be a lot easier if we see this in the table up here. Looking at the table in part A. Just like we did on the linear, let's look at how much we're adding or subtracting between each set of numbers. So from -2 to -5, that is a difference of -3. We've subtracted 3. Then going from -5 to -14, obviously that's not the same value, it's not 3. And we could also test and see that we're not multiplying by the same value either. So look at this difference, -5 to -14, we have subtracted 9. From -14 to -29, we have subtracted 15. And from -29 to -50, we have subtracted 21. So the second difference means that we need to go through now and look at what is the difference of these numbers. And if that is a consistent difference, then we do have a quadratic function here. That's how we can test. So from -3 to -9 is a difference of -6. From -9 to -15 is again a difference of -6. And from -15 to -21 is again a difference of 6. So this is our second difference. Okay, and when we have a second difference that is, they're all the same, then this is a quadratic function. On the first several problems of your assignment that goes with this lesson, you'll be looking at tables like this, and that's all you need to do is you need to identify, is there a common difference, is there a common ratio that you're multiplying by, or do you need to go to the second difference, and if that is consistent, then it's quadratic. The other thing that we're looking at in this unit is how do these functions grow? Some grow faster than others. We need to look at how we can compare those. And so for that, I want you to turn just to the next page, 355. And we're looking at number 3. It's asking us to compare f of x, which is 3x plus 2, g of x, which is 2x squared plus 3, and h of x, which is 2 to the x power. It says show that h of x will eventually exceed the other two. And to do that, we're going to make a table. And I would make it a pretty big table. And we're going to have our x values. And then we're going to have a column for each of those three functions. Okay, so the first one is f of x, which is 3x plus 2. And that is our linear function. The second one, g of x, equals 2x squared plus 3. We see it has an x squared, and that's what makes this a quadratic function. And the last one, h of x, equals 2 to the x power. the x as the exponent, and so that's how we know it's exponential. And I want to compare these three functions at specific x values. We're going to look at x values of 4, 6, and 8, and see how these functions are growing over that time period. Again, that is our exponential. So to find this, I've got to plug in the values into the function. So this first one will say f of 4 equals 3 times 4 plus 2. And we do that, put it in the calculator, whatever you need to do. That's going to give us a value of 14. We'll look at our quadratic and that same x value. We're going to get g of 4 equals 2 times 4 squared plus 3. And you should get a value of 35. And our exponential, h of 4 equals 2 to the 4th power. And that's going to give us a value of 16. So at the beginning, our quadratic is the highest value. The other two are very similar. But we're going to look at how do these grow over time. And the question tells us h of x will eventually exceed the other two, or it will be higher at the same x value. So we're going to see that happen as we work through these other parts of the table. Plug in a value of 6 for this. F of 6 equals 3 times 6 plus 2. And that should give us a y value, or f of 6 equals 20. Move over to the quadratic, and we see g of 6 equals 2 times 6 squared plus 3. And that one comes out to be 75. And our exponential, h of 6 equals 2 to the 6th power, which is 64. So now we notice, moving to our value of 6, that they're all growing. The linear is growing fairly slowly. The other two are growing quickly, and they have much higher values at this point than the linear function does. And as we move on to our last one, we're going to see that this exponential function jumps ahead and is growing much faster than the others. Even though the quadratic grows quickly, the exponential is going to grow even quicker. So we look at f of 8 equals 3 times 8 plus 2, and that is 26. G of 8 equals 2 times 8 squared plus 3. Jumps all the way up to 131. But the exponential, h of 8 equals 2 to the 8th power, is going to give us a value of 256. So we can see that eventually the exponential is always going to exceed the other two. It's a faster growing type of function, even if it starts out slower sometimes. You'll have a question similar to this on your assignment. I think it will even give you the values that you should plug in like this. If it doesn't, you pick some values and just demonstrate that the exponential is growing faster and eventually passes up the other two. That's all for our notes today. Good luck on this assignment and all of your digital learning that we're doing. Hope to see you all back sometime, and bye.